See students, here I am giving one notation. N, you know what is this symbol? This is symbol for subset. What is subset? All the elements, I am writing that subset. You are not having an idea about such. Now I am giving a small explanation about subset. A is subset to B. It means that all the elements in A are also elements in B. For example, A I am taking 1, 2, 3. A is I am taking 1, 2, 3. B I am taking 1, 2, 3, 4. This is B. The inside one is A. In A, how many elements are there? 1, 2, 3. In B, how many elements are there? 1, 2, 3, 4 overall. That means all the elements of A are also elements of B, and then more than some more elements in B. That means A is subset to B. That means that once easily we can understand the series. Natural numbers is subset of the whole numbers. All the natural numbers are also there in whole numbers, no? That is the reason. Natural numbers is subset of whole numbers. Again, it is subset of integers. These are all subset. This integer set is subset of rational numbers. This is the subset of real numbers. Once again, n is for natural numbers, W is for whole numbers, this is for integers, this is for rational, and this is for real numbers. Is there any next set? Up to now, we are discussing about real numbers. What is a real number? The combination of rational, irrational, real numbers. Okay. Then is there any next set? Yes, one more set is there. That set, about that set, we are going to learn in your next previous classes, in future classes, like intermediate, like that. Then that set is also there. That set is complex number set. C, capital C, complex number set. Those are all contains the numbers of the form of A plus IB, imaginary numbers. A plus IB, the combination of real and imaginary. The numbers are look like this, A plus IB. Example 2 plus 3A or 2 minus 3A, like that numbers. Okay, that is, we learn that about that complex number set in your future classes. Then, okay, now we learn about this. Now I have some questions. My question is, I'm going to write some questions based on this knowledge, based on that previous knowledge, previous video. 0. My question is 0 a rational number? Is 0 is a rational number or not? My question. Before I explain that, how to identify rational numbers are in the form of P by Q. But here there is no denominator, there is no P by Q. How? Yes, the 0 also a rational number. 0 also a rational number. What is the reason? We can write by denominator 1. Now there is no value change, there is no change in the value. 0 by 1 also indicates 0 only. Then it's look like P by Q. Here denominator is not equal to 0. Okay, everything satisfied. Then the 0 by 1 is a rational number, belongs to Q. 0 is a rational number. Like that, I am taking 5 number. 5 what type of number? Natural number, whole number, integer. Yes, I am taking 5. Is 5 integer? I am taking okay. I am taking a 5 is an integer. I am giving like that. Integer. Every integer is a rational number or not? Every integer. I am writing one minus 3, minus 2, minus 1, 0, 1, 2, 3. I am taking some integers like this. My question is, every integer is a rational number or not? Yes, every integer is a rational number. But what is the reason to find rational number? Definition is, rational numbers are the form of P by Q. But there is no denominator. We can replace it by 1, by 1, by 1, by 1, by 1, by 1, by 1. Then everything is look like a P by Q form. That means all the integers, remember this point, all the integers are also rational numbers. Every number we can write P by Q form. That's it. Okay, now I am having some questions from textbook. Every integer is a rational number. Give your comment. Just now we discussed. One more point. Every rational number is an integer. Every rational number, given question like that. Every rational number is an integer or not? That is the question. Every rational number is an integer. That means a rational number. I am taking one example. Rational number 3 by 4. Is it a rational number? Yes, rational number p by q form. The question is like that. Every rational number is an integer. Yes or no? No. Reason is this is a rational number, but is it an integer? How integers are like that? -3, -2, 1, -1, 0, 1, 2, 3, 4. That means whole numbers along with negatives of natural numbers only. There is no fraction form. There is no p by q form in the integer set. Okay, then answer is no. For what? Every rational number is not an integer. That's it. Okay. Now let us go to representations. Already you know, in 8th class you learned that representation of rational numbers on the number line. Now I am giving one more model questions. Finding rational numbers between two rational numbers. Now I am taking a number line. I am taking a number line. This is a 0 I am taking. This is 1. This is 2. This is -1. Okay, this is here is this. 0 is a rational number. The 1 is a rational number. 2 also rational number. -1 also rational number. These are all rational numbers. We can write by 1, by 1, by 1. That's why we are saying that those are all rational numbers. Between these two rational numbers, how many rational numbers are there? Between these two rational numbers, how many rational numbers are there? How many rational numbers? Between 0 and 1. Is there any rational number? Is there any p by q form number? There. What is that? 1 by 2 is there in between? 1 by 4 is there in between? 1 by 8 is there in between? 1 by 6 also there in between? Between these two. 1 and half there, 1 by 2. 1 by 2 there. Between 1 and 2, 3 by 2 there. 3 by 2 there. Between 1 and 2, 3 by 2 there. Okay. Now like that, this is 0.5, that is half, 1 by 4 there. All these numbers are there between these two. My question is, I am giving some model questions. Please give answers to that. Between 0 and 2, between 0 and 2, what is the integer? How many integers are possible between 0 and 2? How many integers? How many? Between 0 and 2, how many integers? Only one. How many whole numbers? Only one. But my question, I am changing my question. Between 0 and 1, how many rational numbers? One rule is there, Nana. Between two rational numbers, there are infinitely many rational numbers. What are those, Nana? Between these two rational numbers, not only these two, any two rational numbers, between two rational numbers, infinitely many, these are all rational numbers, infinitely many rational numbers are possible. This one is a density property. What is that, Nana? Density property. Once I repeat it, what is the property? Density property. What is the density property? States that between two rational numbers, there are infinitely many rational numbers. Many rational numbers. We can take that 0.1, 0.2, 0.3, 0.5, 0.6, 0.7, all the decimal expansions. The terminating, non-terminating, repeating. I explain those afterwards. These two, in between these two, 0.1, 0.2, so many other 0.001, 0.002, 0.003, all these are rational numbers only. The infinitely many rational numbers are possible between two rational numbers. This property is a density property. But we have some questions to find rational numbers between two rational numbers. They give two rational numbers, is asking 5 rational numbers or 10 rational numbers or 20 rational numbers, like that. We have some method, some procedure to discuss. By taking some examples, we can find out that. Okay, let's see. Now I am giving question. Finding rational numbers. Find 4 rational numbers. Already this you learned in 8th class. 4 rational numbers between 3 and 4. 6. Between 3 and 4. It is asking find 4 rational numbers between 3 and 4. Okay. For this, we are having total 3 methods. Last year, we follow one method. Here also, first I am doing this by method 1. By method 1, 3, I am writing 3 here, is the 4 here. 3, 4. In between 3 and 4 is asking 4 rational numbers. 4 rational numbers. 4 rational numbers. Then what we do is see this. What is simple solution I give? How many rational numbers are required? First you see that. Find 4 rational numbers. That's right. 4 rational numbers we need to find. That means you take that one as n. N. Add 1 to that. How many is required? Add 1 more number to that. 4 numbers required. Add 1 at 5. Number 5. Multiply and divide with 5. Each and every number. 3 I am taking. Multiply and divide with that number. Second one, 4 into 5 by 5. And then the first number is converted as 3 5s are 15 by 5. First number 15 by 5. Second number 20 by 5. 20 by 5. And the first number is converted to 15 by 5. Second number is converted to 20 by 5. Now, once again read the question. Find 4 rational numbers between these two. Between these two. Is asking 4. Can we write 15 by 5, 16 by 5, 17 by 5, 18 by 5, 19 by 5. That's it. Those are the answer. Then the numbers are, therefore, numbers are, what are the numbers? 15 by 5 given. Then 16 by 5, 17 by 5, 18 by 5, then 19 by 5. This is 4. Very easy. This is one method. Okay, no? Then last year what we done? Same, divided by 10 into by 10, like that we did. Okay? Any number. We can write not only this 5 into 5. That is next method, we discuss that method afterwards. Okay, this is one method. Can you do this? Once you pause the video and copy this. Once again I repeat, given numbers are 3, 4, is asking only 4 rational numbers. How many rational numbers are possible between 3 and 4? Infinitely many, according to density property. So many are there. But he is asking just 4. 4. Add 1 to that. 5. Multiply and divide with 5. Multiply and divide with 5. And then first number is converted to 15 by 5. Second number is converted to 20 by 5. Then write those 4 numbers in between that. In between that. Okay, now this is a simple method. Now let us go to next model question. In this method only I am giving the next example.